Hello and welcome back. Today on the bench is the preamp, and we're making good progress. There's just about most of it's done, I think. I'm just doing this last shielded cable that connects the RCAs at the back to the selector switch. Let's have a zoom in and I'll show you what else I've been up to. So, as you can see, we've got the decoupling caps mounted in there. Got a red wire here, comes in, that's from our socket from our power supply into a fuse. I've just got a 1 amp fuse in there at the moment for the purpose of testing. And then we've got a couple of resistors here. These are 4K7. I needed 3K6 or something really, but these were all I had to do the job, so we'll try those first. Blah blah blah, in they come. So there's a HD, and this is decoupled obviously by this 4K7 and a 47 microfarad cap. And then we've got our anode resistor going over to 1 volt socket here, and the same goes over to here. Let me just zoom in a bit. I've changed the what are they? I've changed the cathode resistors to 390 ohm. We had 270 ohm in there before, and yeah, I wasn't quite happy. It was biasing the valve too hot. It was biasing the valve too hot. So to up this line, this is our load line. If it is towards the 0 volt grid line, then there's a problem, because when you start biasing a valve that hot, then there's a chance that some grid current can flow, and that basically distorts the signal. So we just pushed it down this way a bit more. So that was the major change regarding values. As you can see, we've got the RCAs mounted in. Got a bus bar running all the way along. That is grounded. I'll spin it round. That's grounded here. Oh, you can't see. That's grounded here. We've got our selector switch, which I was just talking about connecting. I've just got one more bit of wire to go there. They're temporarily just tacked in at the moment, because what I want to do some harness wiring there, just to keep all those cables tidy. We've got our volume control in there. I made a cock-up, which I'll talk about in a minute, regarding the power supply. At the moment, this volume control, it only draws about less than 50 milliamps when it's working, when the motor's going. So that is currently, and hopefully it will stay that way, powered off the 6.3 volt heater supply. I'm not quite sure whether that will cause us trouble with some sort of interference flowing back and getting into our audio stream, but hopefully that won't be the case. And then we've got, you can see down in there, we've got a couple of LEDs. This is a power on LED, and this is our infrared LED. This is all working. As you can see, we've got in, put there, output, and that goes to our valves there. Here's the power supply. I've made some changes as regards that, because it was quite a bit of a time had passed between me making this. I'd forgotten what I'd done, and yeah, I was completely surprised when I came to finish it off, and so I had to make a few changes. So the first change was that originally, when I built this, I was intending to power the heaters in series, 12.6 volts, and of course that was no good. That was no good because I'd wired the valves up for parallel connection. And also, when I came to measure the output, I'm not quite sure what had happened, but it was floating all over the place. So basically what I had in there was an LM7812 floating off ground with a diode. and that didn't work. I think it didn't work basically because the diode only conducts current one way. It has to sink and source current, so that was no good. So what I ended up doing was changing the where do you call it, 7812, LM7812 for, what did I change it to? Oh, I changed it for the LM317, and then we've got a tip 3055 as a series pass transistor. So all that LM317 is doing is just setting the voltage so that we get 6.3 volts here out. I think that's a better arrangement than what I had before anyway. I'm hoping though that this doesn't get too hot, because there's about 16 volts here on our reservoir capacitor, and that's a little bit too much really for the LM317 to handle, although it's not really pulling any current because, you know, the series pass transistor is doing all the heavy lifting. I could have just used an LM317 because altogether we need 1.2 amps, and that's within its sort of specification, but there's a problem. When you power your heaters up for the first time, this can make the LM317 either shut down or go unstable because there's a big inrush of current. And so I've found this in the past, it's best to use the 317 with a series pass transistor. So that's the heaters covered. So what I did when I wound this toroid, I had this winding which is about 6 volts AC RMS, which I was going to power the volume control in the, where do you call it, in the preamp. And then yeah, obviously I forgot about that, wired this in. So what I've done is I've used that 6 volt winding to power this 6 volt relay, double pole single throw, and that basically just cuts, just cuts the HT so that there is no possibility of somebody touching high voltage. So when the power's cut, that relay goes off, no high voltage here. I've painted the panel, the front panel that goes on the, this way isn't it, goes on the amplifier. We've got a LED indicator, power on indicator that runs off that 6 volt AC, and we've just got a small diode reverse biased across the LED because LEDs don't like being powered off AC. They've got very poor reverse bias. Reverse bias. They've got very poor reverse bias, so that's there to protect that. So that's that. I'll go in there. That's all ready to go on. So the next thing is the interconnect. So where are we? That will sit like that. Oh, where's the interconnect gone? Oh, there it is. So that will sit on there like that. What I'm going to have to do though is make some sort of feet to stop that sliding about. I've got a couple of top hat screws as mentioned in the last video, I think. Oh, I can't remember. No, yeah, they're just a couple of top hat screws, bolts, nuts, whatever. And that fits in there like that, and then this fits in there. But with this one I couldn't do it like that because I've only got 2 of these top hat things, and I've looked online and I've no idea where you could get them. So with this one it's just got a single screw, and so that fits in there like that. Screw that up, like so, and there we go. And so this is just some, you get like this shrinkable sort of sleeve, nylon sleeve, bit of that on there, a couple of bits of heat shrink. They're individually heat shrinked, all the pins, so hopefully that should be safe. and yeah, I don't think it looks too bad, to be honest. I went to do a test power up to make sure all the voltages are where they should be. Right, this is one good reason why it's a good idea to have a variac and a lamp limiter to power up stuff. I hope you can pick this up. As you can hear, my transformer, that's an isolation transformer in there, is making horrible noises. So to try and isolate it, we've got three things it could be. It could be in here, in the isolation transformer down there, here or here. So let's switch this off there. Okay, so it's happy. So that's cut power to here. So there's something wrong in here. I've already disconnected the preamp, so we know it's not the preamp. So the next thing to do then, if in doubt, you should always pull the plug before you start working on anything. So you should always pull the plug. That way you know 100% there's no mains going there. So it sounds like we've got a short circuit somewhere. So what we need to do is take some resistance measurements. It's obviously got a short somewhere, I think. I've had a look in there and I can't really see anything that I've done wrong. On the last power up, the only thing I've done since the last power up is solder that in. This LED, I was going to call it a DVD then. So we need to check the primary. So what I'm going to do, I've already, there's another good thing you should have always, is a cap discharger. Make sure they're discharged. And let's take some voltage readings just in case. This is on another meter, this is. Right. The other thing I've done is soldered that in and put a fuse in there in the HT circuit. So, sorry, I've got the wrong meter. No, I haven't. I've got the, let's try again. I've got the right meter, I've got the wrong leads. Check our voltages. Right, safe to go in. Bang it on resistance. So this is going across the HT winding. Oh, sorry, I got it on continuity. Right, that's saying that that is 51 ohms, 41 ohms. That sounds like it is the problem. So what the devil? Why is that? Right, I'm going to do some probing and I'll get back to you. I hope you can see that. I've had to tilt the thing forward so you can see it because of the glare. That's reading 24 ohms. Everything was working fine. The only changes I've made is put in 100k resistor across the reservoir cap, solder the LED in, and this fuse. So we've got 29 ohms. Should be higher than that. Just taking the fuse out. 6 meg. So what the devil? This is somehow shorting to ground. Let me investigate. Right, we're on wobble cam. So I've narrowed the fault. It isn't the HT. I don't know what the hell is going off. I suspect I've wired this relay up wrong or something. So I'll just power it up. So what I've done, I've just disconnected the LED because I thought it might be that, but it isn't. So the relay is out, powering up. Should turn the bugger on. No problem. So what have I done here with this relay thing? The only thing I can think of is we've either got a short from this winding. The only thing I can think of is that we've got a short between this winding and the HT winding or something. So after sorting out the non-issue with the relay, we have another issue which hopefully I'll be able to demonstrate. Oh, no, I won't be able to demonstrate because it's not on your peanut. Right. See that? So when I powered this up the other day, this was farting sparks here, a bit like my old girlfriend. So as you saw, that resistor was starting to burn out. We've got some blackening there, so we've got a short somewhere. When I powered it up the other day, this was sparks coming off this connection here. So after checking everything out, pulling it all to bits and what have you, I found out where the short is. Oh, I don't know if you can see down there. Where's my pointy bit gone? I don't know if you can see down there. We've got two red wires going to this valve base, this octal valve base here, which, you know, goes to the relay. And as you can see, this standoff here is basically shorted electrically to the chassis, which that capacitor over here, the ground, is connected to. And as you can see, I don't know if you can see just down here, we've got a red wire, and that is touching that standoff. I'd try to protect the other side by putting some plastic sleeving around there, and obviously it needs some this end too. So I think that's the short. I'll get that sorted and then we'll have another go at powering it up. Okay, that's the standoffs on the relay, insulated, and I've also insulated the pins on the octal socket, on the relay socket. So let's try having a switch on. We've got this meter monitoring the HT in the preamp itself. There we go, 280 volts, and the volume control is working, which you probably can't hear because of me waffling and it's very windy out, which I've got to go out there in a minute, go and do the shopping. Hurrah! So next thing then is to try it with both in. Here we are some time later. I've been and done my shopping. It's powered up, it hasn't started farting sparks, which is excellent. Our voltages down here are lower obviously than what I had before. We've got 278 volts HT before it's smoothed and all that. Well, no, where are we? After it's smoothed, I think. Let me just check that. I think I'm talking rubbish again. Let me have a probe over here. Shite. Raw nips on a stick. 276. Right, stop doing that. So the HT is 276 here, and then what I had to do earlier on was replace that drop-in resistor. It had gone high in value from all the short circuit current going through it. So it was reading something like 6 meg. So obviously we were getting a massive voltage drop across it, which isn't good. So blah blah blah, that's all good. HT is a bit lower at this end due to these me using 4K7 drop-in resistors on the decoupling RC network thingy doo dah. Blah blah blah, that's in there. Sorry, I'm sort of riffing as I go along. Everything is working lovely. I'll point you up here. As you can see, got a nice sine wave coming out. Got 1.6 volts at the moment coming out, 0.5 volts going in. A THD is 0.1, and where's our, there we go, we've got our remote, so we can turn that up. Oh, so you can't see the volume control, can you? Down, up, and I'll do the same there. Sorry, reduce, up. Let's see how far. Let's see what we got out of it. Oops, sorry, I'm not punching it at the thing, I'm punching it at the scope. Sorry, trying to do this. Right, that looks like we're maxed out there. Still 4.9, let's just call that 4.9 volts. 0.1% THD. But that's what we want, that's about right. I mean, we're using valves, so yeah, we'll not have to really blow distortion. Well, I'm not anyway. I dare say we could get that down a lot further if we wanted to change some values, mess about with the HT and all that, but that's fine by me. So what's left to do? As you can see, I've just tacked a decoupling cap here. Obviously, because we don't want DC. What have we got? 117, 112 volts on the two cathode followers. I was going to use these Weimar MKS 4.7 microfarads 100 volts polycaps. But obviously they're no good if we're sitting at 117 volts, 110 volts on the cathode followers. They might hold up, however they will, I don't know, or will they? I'm not quite sure whether they'll see full HT when it powers up. So what's left to do then? Going to put another one of these paper, I think this is paper in oil, paper in something or other, capacitor. Sorry, it's been a long day, I'm probably talking nonsense. Yeah, I've got to put another capacitor in, put that in properly, obviously secure them in properly. What else we've got to do? Right, let's knock that off. Let's turn it off with the switch. Oops. There we go. That's a HT drop in. Yeah, so what we've got to do, obviously put another cap in for the other channel, secure that in properly, and then the other thing we've got to do is raise our heater voltage up to about 50 volts, so the heater cathode voltage is within spec. I'm not quite sure what it is for the 6CG7. It's usually about 100 to 200 volts depending on the species of valve. Yeah, I know I just said species. Yeah, so everything's good. I'm happy so far. Bit more work as mentioned, and we've got to put some sort of feet on the top and on the bottom of this preamp so it's not sliding about, because yeah, I mean, I've sort of gone a bit bonkers here and made that really short, but I think really this ought to sit on top of the power supply anyway. You don't want a great big umbilical. For a start, we'll be dropping voltage on the heater wires, on the heater wiring, unless we put in like massive great bloody thick wiring, which we don't want to do. Yeah, and it just keeps it neat. So I'll stop waffling, go and get this edited and posted for your delectation and watchability. Yeah, I'm talking bollocks now, I'm tired. Right, thank you all very much for watching. Should be another one of these, I would think, coming up just to finish up. Take care of yourselves. Ta-da for now.